the making of series of videos for Carrier Command 2. These videos are around bits of technology that we've developed that we're excited and proud of. They may be unique in themselves, or they create some kind of unique gameplay aspect that you'll only find in Carrier Command 2. They are simply cut from recorded discussions between developers. They're very informal chats. They can be technical, so I apologise if we don't fully explain any aspects, but hopefully they give an interesting insight into the game's development. Enjoy. So we've got the wind information, and you can kind of see here there's these kind of like these swirls and vortices, and there's high wind areas and there's low wind areas, and kind of everything in between. And this is very much inspired by, I would say, windy.com, isn't it? Kind of the weather data that you've got there and the weather visualization that you've got there. Is pretty cool just to see all of that working. But in Carrier Command 2, the weather data, it's as is described on the map. So if you go to all of these different places, the weather data will be different. But of course, it may be different when you get there because this is continuing to develop. So this is a fluid simulation where we are essentially pushing particles around, I guess, in a kind of a 2D sense. So there is flow that is modifying and changing and continuing to develop, and these vortices will continue to swirl. And I captured some footage yesterday. I will put it on screen. I don't know whether what we're actually going to see. I haven't watched it sped up yet, but I imagine we'll see some interesting fluid simulation where the stuff's developing, and it's quite a detailed simulation, but it does need to update very frequently because of course the weather isn't necessarily changing second by second, but more kind of minute by minute. So we're kind of slowly moving the simulation forward, and it's just slowly creeping forward. So we've got various layers of the data here. We've got the wind data, we've got rain data, and here with the very high precipitation areas, if you've got very high precipitation, I think that means you also may get lightning, thunder and lightning. So that's also driven by the rain data, but you can see here there's kind of a slightly higher contrast. So you are getting big areas with no precipitation whatsoever, and then it starts to creep in with like light precipitation. And then here you can see some very heavy rain and some big storms, and likely thunderstorms in the red areas as well. But then there's a lot of area. I think it's probably about 2/3 no rain, 1/3 is about rain coverage, I would say. And again, you get these really interesting kind of like organic swirling patterns that are entirely generated from the fluid simulation, and it's a very similar situation with the other layers. Again, the fog I think is getting moved around with the wind, so the fog is getting pushed. I think if you were to compare the fog and the wind layers, I think they have a certain amount in common, i.e. the wind is pushing the fog around the world. And then the ocean current is a different layer. I missed that because I've got my mode on. I'll just change that back. The ocean current is a different layer, so it is independent of the wind and rain and so on. This is the ocean currents. So you can see there are kind of like thermal currents in the oceans that are pushing. You can see there's areas of very low current, and then there's areas of very high current, especially in the open ocean. And within the islands, the currents do tend to be a little bit lower, and this is because the islands themselves have kind of like they resist the flow. They dampen the flow of the ocean current, where the island is shallower, where the water's shallower, the current is reduced. So you tend to get the flow kind of pushing between islands, and you can see the flow kind of splits to go between islands, then it'll merge again, and again it's all fluid simulation generated, but of course The flow is just is changing and modifying over time. I suppose the important thing to mention is the impact that these effects do have in the game. You've got the wind simulation is obviously pushing your aircraft around, it's pushing your carrier around a little bit on the water. The current has a big impact to the speed of your carrier. It will pull you, I think, at the highest currents, I'm going to guess 20 knots perhaps, for some of these strongest currents. So you can see that you could use that to your advantage to gain 20 knots if you plot your course such that you will be catching a current and it'll be taking you towards your objective. I think in this case here we could very easily get to our first island if we chose this one on the top left. Likewise, if you're trying to go up current, it's going to be a lot slower. But also likewise, you can also use the current data to know that you're in a PvP situation or you're fighting an enemy carrier. You'll be able to use currents to your advantage and maybe try and push the enemy into a current that they don't necessarily want to be in, or so on, or use a current to escape, and so on. So there's quite a lot of speed differential you could generate from there. The fog is obviously important for visibility. Precipitation at the high precipitation levels, radar doesn't work if there's a thunderstorm, because the electrical interference, I suppose, is part of the game narrative. The final visualization is ocean depth. This isn't part of the fluid simulation, other than it does influence the ocean current, or the ocean depth. Where it's shallower, it does dampen that ocean current down a bit, and it just causes the current to flow mostly through the deeper areas, and it flows most easily through the deepest areas. So in terms of how that's working, we've got a series of textures that are being rendered. So first of all, that's the ocean simulation. Actually, well, not all of it is. This bottom one is in fact the ocean current texture. You can see here this is kind of the ocean depth texture. At the top there's the ocean waves we'll talk about later, and then this texture at the bottom is the ocean current, and the red, green and blue all reflect different properties of the actual current. I think red and green is the direction, so it's not scale, so these values are going above 1, so you don't see the full range of values in this texture here, but the water in red, where it's red, would be flowing to the right, where it's green it would also be flowing up, and likewise in the black areas it's probably gone into negative values, so you can't see the information there. But interestingly, you just see there's a lot more detail in this area here, and that's of course where all our islands are within the world. And so the flow is a lot more interesting and intricate, and this is simulating at 2 updates per second, so it's a very slow rate of updating, but the flow is slowly changing, and that will update over time. It also wraps around, so this texture does wrap around. So you can see that green there matches up with that green on the side, and all the other bits should in fact match up and wrap around on the texture. And then if we have a look at the ocean data 2, this is the weather information. This bottom texture I think is the best explanation, because all of these values are actually in a much easier range to render, and you can see a lot of the wealth of different qualities to the weather, that each unique color in this texture is representing a different place in the world, and I think this is, I'm going to guess, 256 kilometers across, so this is a huge area, and each area in the world has its own unique weather property, where each unique color is a specific type of weather, and I think this top texture is probably the wind velocities, and that's driving these colours to get pushed around the world. And of course, if you look at the wind data, you can predict to some effect where the weather is going to move, because the weather is going to get pushed around by the wind. And so as the wind pushes the weather around, you can see, well, that weather is going to flow along with the wind and move from that location to that location. And so you can predict what's going to happen to some degree. There's a lot going on there. Do you have anything to add to that?
No, I don't think so. I think you covered everything there.
That's all synchronized when you join the game, but it is also deterministic. So players receive the weather data when they join the game, but it also simulates on their computer, and their weather updates in the same way as it does on the server. So yeah, I mean, that's the simulation that's driving that. In terms of the visualization, we've got the little particles. They're kind of inspired by the windy.com weather stuff. If you've not checked that website out, it's pretty interesting. And they've got these really nice particles that just kind of flow and just I suppose visualize the direction of movement of in our case we're visualizing the direction of flow of the wind and also the ocean currents. But yeah, quite a fun context to be adding weather simulation in. I suppose where it's more kind of relevant that we're in this lucky situation where we're building a game that can really benefit from the weather simulation, not just in terms of a visual and a graphical sense, but actually there's quite a significant impact to the gameplay in terms of the ocean currents and the effect the wind is having and the effect that rain is having, and these I suppose small buffs and debuffs that you can potentially apply if you're trying to really optimize your strategy, especially when you're playing in a PvP situation. Having a 10% advantage by using the weather to your benefit can be the difference between victory and defeat. So I'm quite interested to see how players interact with that and how they make use of it. Again, with that, we've also got the day-night cycle and so on, and all of this interacts to create a very rich, dynamic, changing world that's always going to be different depending on where you are in the world and what time you're at. It's just constantly changing, which is pretty cool. I think that covers the weather and the ocean stuff. Other than to say, while we're just looking at those textures, I'll just quickly talk about the ocean. A lot of players have kind of assumed this must be the same technology as Stormworks, and in fact, I think pretty much everything in Carrier Command 2 is new code, and it's new systems, and the ocean actually works in a completely different way. In Carrier Command 2, it's just simple Gerstner waves, and they simulate at 2 ticks per second, as opposed to the Stormworks waves that simulate at 60. And in this ocean texture, this middle texture here is in fact the waves texture. It's a lot larger in scale than the Stormworks stuff, so there's more data there, and it just means that the ocean doesn't repeat as frequently. And that does have the benefit of it being very difficult to see any kind of repeating quality, whereas if you zoom in out on Stormworks, you can start to see certain waves kind of appearing on a grid in certain situations. In Carrier Command 2, it's a lot more difficult to see the repeating. We've also got bigger waves, and just having the larger scale. We've got less in terms of the smaller scale of waves, but I think that was less important for the game, and we were looking to really expand the scale of the ocean and bring out the scale of the waves a little bit more. I might also see if we've got some debug rendering for the ocean, because there's a little bit on there, isn't there? We've got this ocean wireframe, so we can render the ocean as wireframe, so you can see where the triangles are. But most significantly is we do also LOD the ocean, and we've got some kind of blending zones where we blend between the ocean data, so you can see there's much bigger triangles, and in fact they've just kind of doubled in detail as we got closer to them, and this creates a situation where I'll just detach my camera. You can start to see how the ocean's working, in that we've got the level of detail is just jumping up as we move around. And as you go further away, there's less detail. And it's a pretty common technique in game development to be subdividing stuff as you get closer. It's quite common for terrain, for example, and we've just used the ocean to accelerate the ocean. With Kara Command, and the distance you can see is ridiculous. You consider there's our carrier, that's several hundred meters long. If we zoom out, you see just how big this world is, and I think it's still. I just reduce my field of view there. I mean, you can see all the way to the horizon, and there's still ocean there. So the amount of the ocean rendering is probably kind of much improved based on Stormworks, but I think specifically for the requirements of Kara Commands that we have gone for less detail close up, with the preference of just having this bigger world. So yeah, that's that pretty much all covered. Do you have anything to add?
No, that's awesome.
Awesome. Well, thank you very much for watching this video. There very well could be more of them. And yeah, we'll see you next time. Thank you very much.
See ya.